Okay, let's start this again. Okay, share my screen again. Okay. So we'll start with print hello world again. So you open your web browser, go to Google Colab, and then start with new notebook. Okay. Give me thumbs if you already done this and you're ready to continue. Okay. Others? Only one? Sorry. Can I continue? Others? Guys, okay. Give me thumbs, whether the screen or the reaction. Okay, okay, 2, 3. Okay, one more. Good enough. Okay, or you guys, I guess I don't want to rush you guys into this program. Okay, now in previous week we learned the kind of the basic Python, basic programming. Now tonight I'm going to show you more advanced stuff, but this is just a sneak preview of what Python can do. Let me open another cell. Okay, now in Python, one of the things that makes it interesting, it has a large number of modules or library or functions, so you can call them without 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 I'm not going to say difficulties, but most of the time it's flawless. Okay, so right now one of the libraries that are common in Python is the number library. So to import a module or library, you use the word import. So let me just click on this and then start import. Import numpy. This is number library as np. So this is a standard way to importing library in Python. You import numpy as np. You import a library called numpy, and we're going to call it np. In this programming, we're going to call it np. The reason we want to use np because it has 2 characters instead of 5 characters. Numpy. We don't want to type in numpy, numpy, numpy. Instead of typing numpy, we'll just type in np. Okay. So, for example, now let's do an array. Let's create an array. Say, let's do this. A is equal np array, whatever it is, and then let me print A. So what it does is, wait 1 second. Okay, let's do this. Okay, so it's basically prints a matrix. Let me just copy this one. Let me just pull it out, put it in your chat section. So with this numpy, you can change, say, like the first row, you can say change it to 9, whatever, right? Can you run it again and it says 9 to 7? This is the first row. The second row is 4, 5, 6. Third row 7, 8, 9. Okay. So obviously you can create 2 matrices, and then you can add, multiply, find determinant, and so on and so forth. So this is basically standard numerical. If you have some sort of numerical programs that you need to do, all you have to do is just call numpy, and it will do it for you. Okay, I'm not going to do that in this lecture. It's just to know that you're going to use numpy if you're going to use numbers, all kinds of number processing. Okay. Okay, good. Or give me thumbs so I can move. Okay. Now let's start with another one. Okay, assuming I want to, sometimes you want to create random numbers as part of your simulation, data set, or whatever. So let's do this again by creating import. Okay, numpy as np. Now I'm going to create this time. Wait, I'm going to create some kind of random variables. Okay, let's call it berat. And then berat is numpy. Now I'm going to call a random function, and I want to call it random integer. Okay, random integer. And then the low maybe 50, and then the high maybe 100. This is the weight of a person, for example. And then the size, maybe I'm going to create 10 numbers, and then I'm going to print berat. So what I'm doing here, let me just copy this one, copy it into your chat section so you can follow through. If I run this, it will create basically 10 random numbers starting from 50 to 100. If I run it again, it's going to change like 17, whatever, right? So I'll run it again, it will change, it will change. Basically, it will create 10 random numbers, and the number, basically, it's between 50 and 100. The 100 is inclusive, meaning the 100 is not included in the list. So it's between 50 into 99, right? Okay, run it and see, if you can play with. If you want, you can change it. Oh, okay, let me say I want it 100 number, so you can just change it into 100. So you'll see that you'll get like 100 numbers there, 100 random numbers. Okay. So if I want to say create 300, I just change this one into 300 numbers, and then it will generate like 300 random numbers. Okay. Okay. Good. Jempol, thumb. Ada lagi? Oke. Oke. Is 1, 2, 3, 4, 1 more 5. Okay. Okay, ya. So now we can generate this for your simulations or whatever. Now I want to save this one. How do I save this one? I can save it into np numpy save text, save txt, and I'm going to call it, say, berat.csv. Okay, I'm going to create a basically comma separated file. That's the name of the file, and this is the variable that I want to save, berat. Okay, and how do I save it? I'm going to have format. The format of the data that I'm going to save is %i, meaning %i is integer. So if I run this, it will create new like 300 random numbers, and then it will create a file called berat.csv. Now, the file itself, it is actually saved in our Google Colab session. If you look into the left side here, there's a folder. You click on that folder, and it will show you that there is a file called berat.csv. Okay, have a look at that. Now, if you want to see the content of berat.csv, you can actually double click it. I think if you double click it on the right side, it will say, okay, it will say, from 1 to 10, 1 to 10, it will only print 10 on the screen, right? Of 299 entries. Okay. So why 299? Because the first one, it is assuming the first one is the title of the or the heading or the name of the variable. Since we don't have the name, the first one is 73, right? So 73 is considered the name, but so you have 299 entries, and the first one is this. Okay, you can run it again, and it will change. Let me just run it again, right? It says 88, whatever. Let me just close this one first. You use the X here to close it. Close the X here. And if you don't want to see the file, you can close it again, X again, so you have this. If you run it again, it will change the number, and it will save it into this berat.csv. If you double click it again, it will change the. So this is how you create random numbers, and you can download this. Say if you want to download this, if you go to the left side, there's berat.csv. There's 3 dots. Okay, if you hover your mouse on top of the name, there are 3 dots. If you click on 3 dots, you can see that there are download, delete, or whatever. So you can actually download this, and then you can download it and put it into your spreadsheet later on. So, adakah pertanyaan? Good. Just if you don't if there's something that you don't understand, feel free to ask the question before we move on and make it more complicated. Sudah oke kah? Oke ya? Good. Give me a thumb so I can move on. Okay, now we have these numbers, and the variable is called berat, right? Oh, okay. Now it's difficult for me to see what it is. Let's just plot it. I want to visualize it. Okay, now let's move into another code here. Now, to visualize it in Python, there is a library called matplotlib. So I can include, import, okay, import matplotlib pyplot SPLT. So what I'm going to do is I'm going to call to basically upload what we call it module called matplotlib pyplot, and I'm going to plot it. So I'm going to plot the berat, and then I'm going to show it. If I click it, then it's going to be like this. Let me just copy this one again. Wait. Let me just wait. Let me just open this one. Paste it into your chat so we can have. So this is an example of plotting it. Now we can customize the plot. For example, this plot is 2 quarters. So if you look into this is 50, maybe this one 55, 60. I wanted to make it kind of more detailed. So instead of just plot histogram berat, let me just add some option. I have many bins, right? I want to have the bins from bins equal range from 50 to 101. Okay. So let me just run it again, and you can see that, so this is a different kind. The plot is still the same, but it's more detailed. So instead of 50 to 55, combine the data together, you can see that this is 51, 50 through 50, I don't know, 53, 54, 55, 56, and so on. So this is more like, let me just make it smaller. Okay. So this is more like kind of like class view of more detailed view compared to the previous one. If I want to change the color, for example, let me just call it again. Let me just say color is equal red, for example. So I'm just trying it again. So it's going to change into red. Okay. So without these options, Python is going to pick the default. But if you want to change it, yes, you can. The options are there. For example, let me just sky blue. I think there's a sky blue. Let's just run it again. Yeah, there is a sky blue. Okay. Now, if you right click on this, you can save the image. So basically, you can save the image and then use it in your presentation. Okay, now we want to customize it again. Say, for example, well, the x-axis and y-axis, there's a name for it. Okay, let's just add more. Okay, so the x-axis is PLT x label. Let's just label weight, for example, and then the y label is the number of people. Okay, y label we call it frequency or a number of people. Okay, I'll run it again. So it will it will print like not a legend, but kind of label. So the X label is weight, the Y label is number of people. So you can do this. Adakah pertanyaan? Is there a question for this? Just move this one again. Okay. Ada pertanyaan? So what we did so far, we generate random numbers and then we save it into a file. We can view it because we want to find out, okay, what is, the distribution. This one is kind of uniform distribution. Okay? But we can make a different kind of distribution if we want to. Now, okay, so So this is that. Give me thumbs if you want to move to the next one. Okay. Okay. Now, well, for this particular case, we generate the numbers and then we plot it. What if suppose we have, you know, let's generate number again. Suppose we have a file and then we know the file, it's called berat.csv. I want to plot berat.csv. So probably your CSV is generated by your backend, your manufacturing plant or whatever. I want to find out, I want to visualize it. Okay. So now let's start this. Let's create another code. Okay. Now, import. Now we want to import something from NumPy. I don't want to import the whole NumPy. For example, I can use from NumPy. I'm just going to import generate from txt. So basically, I'm going to load a library called generate from txt. Now I'm going to have data is equal generate from txt and then the name of file. Okay. It's not delimiter. Okay. The name of the file is berat.csv. Let me just run it and then let's print it. See, that's exactly what we have in our file. Let me just copy this one, put it in your chat section. Okay. There. Okay. So if you run it will actually read from Berat CSV and then it will print it if you like. Now the same thing, I can, once we have it in data form, I can again plot it into PLT is data. Okay, same thing as before. Okay, let's just do this. Okay, sorry. Okay. Okay, now let me just do this. Let me just close the print, run it again. Okay, so this one is the plot. Okay, let me just copy this one and then put it in your chat section. Okay, so that's the difference between this and that one. This one is the data we actually read it from a CSV file. So again, you have a CSV file. I want to find out what the data looks like. So this is a nice way to do it. Now, what can matplotlib do? Matplotlib do? Okay, let me just go here and then I'll show you what matplotlib can do. Okay, let's matplotlib. What it is? Okay, let's just. What is matplotlib? So matplotlib is a visualization with Python. It has all kinds of visualization. Let's just click on plot types. So you can have plot types. You know, like this one is pairwise pairwise data. You have X and Y. You want to plot it X and Y. So you have different kind of format. If you click on this, you'll see this is the chart, and then this is the data that is being used to generate this chart. So you can see, oh, okay. So this is how you generate this chart, and these are the data. So you can go back here again. So you can have all kinds of plot-wise, and then you have statistical distribution. This is what we did, earlier. We can have box plot, error bar, violin plot, even plot is 2D, and then hex bin, pie chart, and so on. And then you can also grid data. Kind of grid data. You have some kind of contour here. All kinds of complex. This one is gridded, but this one is irregular. The grid is irregular. You can do that. Even it can do 3D and volumetric data. So if you want to plot your data and your data is in 3D, it can do it for you. You can just, for example, I want to look into this wireframe. So this is an example how to generate this data. Okay. So you can also see other section. This is the examples, for example. You can see infant bars, line bars with different colors, multiple data. It can do that for you. So there are many examples here. You can just follow through and see what you can do. So Matplotlib is one of the best visualization. There's another one. It's called Seaborn. Seaborn. This is also the same thing. With Python, you can generate all kinds of data. Okay, let's just click on gallery, so you can have different kind of visualization with this. Okay, so basically, what I'm saying is that with Python, you can do all kinds of visualization. Um, it's just you read data and visualize. Ada pertanyaan? If not, give me your thumbs. Okay. Atau masih confusing? Okay.
Sorry.
Oh, yeah. Yeah, Yuri.
For the NumPy ya.
Sorry, I cannot hear it.
For the NumPy ya.
Oh yeah.
Just go back to the previous formula.
Like this, for example, yeah.
Yes, I have tried this in my Google
Colab.
Google Colab, but it doesn't work yet.
Okay, there's an error. Okay. Okay, show me your screen if possible. Let me just stop my screen. Show me your screen. Import NumPy. Usually it's a matter of typo, comma or dot. Oh, sorry. I have not allowed. Okay, allowed. Okay. Okay, now go ahead. Do it again. Which one? Oh, this one is still the lesson number one.
Sorry. Previously that is sorry. I just stop share first ya. Sorry.
Okay. Coba mana? Show me your code. Okay, coming. That's it. Okay. Go to section 18. Okay. Ke bawah lagi dikit. Oh, it's not save text, but save txt.
Oh, okay.
Yeah.
Doesn't work.
Yeah. Shift, save, np, save. Okay. Coba di run lagi. Run again. Hang on a second. Just see. Okay, wait. np save text. Berat CSV. Okay. The name of variable is berat without the quotes. So you save the file name is berat, but the variable itself not quote berat but berat. Okay. Boom. It works. Okay.
Yes, and for the last, yes, sorry.
Okay, it's same thing.
Formula, yes.
Yeah. That one is again from txt. Again from the import from NumPy import again from txt data. Oh, okay. Because the reason we it didn't work because our code last time did not work, so it is not saving into berat.csv file.
Oh, okay.
Yeah, after that one works, the berat.csv file.
Okay, sorry.
Okay.
Okay, okay. So the NumPy, yeah, is for uh NumPy is for the array of the number, is it?
NumPy basically it's a number library for Python.
Number
So yeah,
library. Okay.
NumPy it's a number, all kinds of numeric number processing. You can use NumPy. There are many libraries inside NumPy. We don't have to know. There are many of them. This is an example is to generate random number, for example.
Yeah, so that the number is randomly
Okay.
spread.
Yeah.
Oh, okay.
It's created random and the distribution is uniform. You can change the uniform distribution later on if you want.
Okay, okay. So that what is the function necessary in the real case?
So the real application of this.
Oh,
So for example, if you want to create a simulation, for example, I need to simulate. Maybe I want to create say an elevator, for example, and I want to have 7 people on an elevator. So let me generate random numbers, assuming there are 100 people, for example, and then let's pick 7 out of these 100 people, for example, to represent our statistic example. So you can use this to generate this kind of the random number.
oh, okay, okay.
Okay.
Okay,
So,
sir. So, thank you, thank you.
yeah. So this is for simulation, for all kinds of what if scenario. Okay.
Okay, sir.
Okay. So that's that. Now, kalau ada pertanyaan lagi, if you have any question, feel free to do that. Okay. Now, let's move on to another plotting. Let me just share my screen again. Okay. Now let's try another code. So this time, I want to plot x against y. Okay, let's see. Import matplotlib matplotlib.py plot splt. Okay, this is kind of standard. Okay, now assuming I have a variable called x1 and x1, let's say I have a list of say 1, 2, 3, 4. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, for example, right? I have 9 numbers. That's x. I have y1, for example. I don't know, 7, 3, 5, 2, 4, 7, 2, 1, 9, for example, something like this, right? And I want to plot it x against y. So I can do plt plot x and y. Okay. So I can do this plt, and then I'll do plt, plt show plot, show plot. Okay, show. Okay. Let's just run this. So boom. Hang on a second. Plt plot. Sorry, plot. Okay, so that's that. Okay, let me just copy this one. I'll give it to you in the chat section. Okay. There. Okay. So this is an example of plotting x1 against y1. So this one is x1 and this one is y1. Okay. So you can see x1. So the x is 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then y1 is that. Now let's see. I have another plot. Say for example, I have a second data x2 is equal again probably only a portion of it, probably 2, 3, 4, 5, 6, 7, for example. I only have 6 numbers. For example. Y2 is equal, I don't know, maybe 1, 7, 8, 4, 3, 1, maybe like this, right? And I want to have also plt plot x2 against y2. Okay, sorry. Let's just plot them. Okay. And plot, sorry. Plot, missing typo. Okay. So you have this plot. This one is, the first one is x1 again, y1. Now, let's just call this one, for example, I want to call this one, give it a label. Let's just label it. This one is label. This one is a product one, product one. And then this one, let's label it label product two. Okay, let's just run it again. Okay. Oh, sorry. I want to show, say, the legend. Okay, plot legend. I want to show it. Okay. Okay. So now it says product one here, the blue one. There's a legend, so we know that the blue one is product one, the orange one is product two. If I want to make sure that the color is red, for example, I want, I don't know, maybe product two, I want to say the color is equal to red, for example, right? So run it again. So this one is red, and then that one is blue. Okay. Let me just copy this one again. Let me just copy this one and give it to you. Okay. So that's an example of basically a XY plot. Okay. Obviously, you can change the data here, for example. Okay. And then also the same thing, the X, there's no label, the Y, there's no label. Say, for example, let me just call, see, PLT X label is a time or month, or I don't know, maybe call it month. And then PLT Y label, number of products. Okay, so numbers of products sold, for example. And then a title is sales title, for example. Just run it. So it says sales title, sales report. Okay. So you can customize the visualization, and to do that it's very easy with Python. Ada pertanyaan kah? After this, we move to a bit about statistics. I'm just going to give you two statistic examples. Ini oke ya? Give me thumbs. Okay. Okay.
Let's go back to the
Yeah.
upright up the upside. No, sorry,
Yeah.
I haven't copied it.
Oh, okay. Look into the chat section. You can copy it from the chat section here.
Yes, for the number
Okay.
of
Oh, okay,
product
sorry.
slotnya.
Okay.
Okay, sir. Thank you.
Oke. Ada pertanyaan lagi? Silakan kalau ada. So again, these are just examples of what Matplotlib can do. Remember, there are lots of examples. I'm not going to show them all, but you can go and see. Oh, okay, that's how I want to create a chart, something like this. Or you can just look at it. Oh, this is how you do it. Okay. Now let's move on to a bit of a statistic. Okay. So now let's do a linear regression. So again, let's start with import numpy as np. Okay. Now, once we do this, we want to create. Suppose I want to create a line. Straight line. I want to create a straight line, and the function is ax plus b, for example. So this is like an example of a line, right? The A is the gradient, B is the place where y cross the zero. Okay, now let's assume the A. This is an example. Let's say assume the A is 0.33, for example, and the B is 0.88, for example, right? This is just assumption. We can change it later on. Now let's say I want to have a number of points is equal, say, 300, for example. Sorry, number of points, this is the variable of points. There are going to be 300 numbers. Okay. Now, let's create a list of empty first. Empty the x point. Okay, let's create an empty list, and then the y point also empty. Okay, so in previous example we just enter the number, but this one we want to create the number itself. We can create random number. Okay, so now let's do this for I in range number of points, right? So I want to create, say, NP, the X is NP random normal from 0 to 1, for example, or from 0, let's just say, okay, let's just do it from, okay, 1. Okay, that's okay. And then Y is equal A, ya kan, A tadi, sorry, A multiply plus X, sorry, plus B. Okay, wait. These things way ahead. Okay, so I have this Y, okay. So the X is there, Y is there. Now I want to add it into our list. So basically these lines generate X and Y, and then I want to add this into our list. So I can say, oh, sorry, wait, X point, okay, X point append Y, okay, append Y, okay, and Y point append Y. Okay, so let's just plot first. Okay, if I plot this one, and let's make it only 100%. Okay. I can do this, and then I can print X point. Okay, let me just do this. Let's run it. Okay, so basically what it does, it's going to print like 100 numbers of X point. This is a list, X point. So I have 100. I can also print Y point, but there's no point in it. I want to see it. Okay, let's just see it. Okay, import matplotlib pyplot SPLT, just like, sorry, matplotlib pyplot SPLT. Okay. Now I want to plot X against Y. Okay, PLT scatter. Okay, let me just use the default color. Okay, and then run it. Okay, so this is what it does. Okay, let me just create again 300 numbers. Okay, let me just copy this one and send it to you. Okay, so you can play with it. So basically what it does, it will create a 300 it will create a list of 300 points. Yeah, 300 points, which is basically a random between 0, the X is 0 between 0 and 1. Wait, how come the X is from -3? Okay. Oh, normal variable from, okay. Okay, because it's normal. Okay, let's just make it 0.5. Maybe let's make it smaller. Wait. Oh, 0.4. Let's just run it again. Okay, so yeah. Okay. Anyway, now, but this is a straight line because the variable is y equal a multiplied by x plus b. Okay, let's introduce some kind of randomness. Okay, instead of y equal ax plus b, let's add some random. Okay, np random. This one is normal distribution, and I want some kind of distribution between 0.0.02, say for example. Okay, so you can see that the dots are not in the straight line, right? It's kind of you introduce some kind of random numbers, but you can see this is kind of straight line. But if you have the random, if you have more values into the random, okay, between 0 to 0.5, so you can see, you know, you have more distributed kind of value. Okay. Yeah, so it's not a, it is straight line, but the data is not exactly on the line. Okay, so this is how you generate the data. Okay. Let me just copy this one, and then you can play with it. Okay, that's. If you want to change the color, you can always change the color here. Sorry. I want to change the color, plot scatter, let me just color equal red, for example. Okay, run it again. So it's going to be red, for example. Right? Okay. Now the same thing, we can save this one into a file, but the difference between the last one, when we save the file, the last one is just random numbers, but this one you want to save it XY, XY, XY. So what we want to do, if I want to save it into a text file, I can np save into a text file, and I can call it line.csv. Okay, and then because I want to have like XY, 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 so the way you do that, it's called np column stack. How do I know this part? Oh, basically I'm borrowing from somebody else's code. Okay, so I can do this. Okay, and then the format is %f, because why %f? Remember in our previous example is %i. %i means integer. This one is floating point, and then I want to have the limiter. It's equal. Basically, I want it to have. Sorry. Where is it? Okay. Okay. Let's just do this. Let me run again. Okay. So now if you look into the folder here, let me just copy this one first so you can play with it as I'm explaining this. Okay. So when I run this, let me just do this again. Let me just change the color. I don't like this, is too bright. Let me just do the default. Okay. So if I run it again, basically it will generate some kind of random. Okay. Points between x and y. It is still aligned, but you can see there's kind of disturbance, and then you can save it into a file called line.csv. If I click on this, there's a file called line.csv. If I double click it, you can see that this is x, y, x, y, x, y, x, y. Okay. So the value is between x and y, x, y, x, y, x, y. Sampai di sini oke? Oke ya. Now, this is how we generate data. Now, this is the fun part. Assuming we have a file or data in that CSV file. Okay, let's just start new code. Okay, let's just import numpy snp, numpy snp. Okay, now I want to have I want to read this. My CSV, for example, my CSV is equal numpy gen from txt, just like before, from txt, kan? Okay, line CSV delimited, comma. Let's run it. So you see, this is what we have so far. Okay, let me just copy this one, and I'm giving it here. Okay, so basically what I'm doing is I'm reading line.csv, and I'm going to put it inside this. Okay, so it's xy, 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 xy. Okay, that's my CSV. Okay. Now, assuming I have this data, what is the value of A and B? So this is what we call a linear regression. We have the data. So if we plot it, okay, this is what it looks like, the data, but what is the A and the B of this line? So what you are trying to do is you're trying to find this line. There are ways to do that, but in the old days, you can use a numerical method to do to find the A and B. Now it's easier for us here. Let's use Python again. Another module called from science, yeah, SciPy import start. Okay, import start. For example, I want to import statistics, and then I want to find the slope. Okay, okay. The slope is the A. The intercept is the value where the line hits the zero line. Sorry, the zero. So that's actually the intercept, and some values for the data. Okay. Now, so what I want to do is I want to have. Let me just do this. Let me just do this. Hang on a second. Let me just make it simpler. Okay, it's linear regression, and our data is. I want to read it. Oh, okay, now I can read it directly from this, right? From my CSV. But to make it easier, because remember when I print it, it says XY, 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 XY. So now I want to save the first column into XP, and then the Y column is YP. There's a way to do that. This is called a my CSV transpose. There's a file called, there's a function called transpose. Transpose, okay. Okay. So if I transpose it, the column between X, Y, X, Y, X, Y. So X is the list of all the X's, Y is the list of all the Y's. So I can use that one, XP and YP, okay? And then I can run it. Let's just run it. So basically it says, okay, the A is equal this, and then the B. So let me just do this. Print A. A is equal that. And B is equal that, okay? If I run it again, it says A equal 0.31 and B is equal equal 0.87. Remember our original, the A is 0.33 and B is 0.88. So it can calculate the line, the slope of the gradient is 0.31, or this is actually 3185, which is basically 0.32, right? So A is 0.32, B is 0.88, kind of. Why is not exactly 0.33? Because we introduce some kind of disturbance here, right? So this is what we call a linear regression. Let me just copy this one. So you can play with it, and then you can save it later on if you want to play with it later on. Okay. Ada pertanyaan?
Pak Budi, I'm still
Yeah.
making some mistake on the previous step.
Okay, show me your screen.
Okay, let me just show my screen.
Usually it's just a typo, but we'll see.
Yeah. So this is my screen, but
okay. So where's the problem? Go down.
Okay, so I'm just want to show you the previous step.
Okay.
In the wait up. Nah, in here I'm making an error, but the next step still following what you are saying in the explanations. So what happened to my typing in here? But
wait.
Even
okay, let's see.
this text, I'm copy it from the chat box.
Okay, let's see. Import gen from txt, data gen from txt, berat.csv. Okay, now if you look, click on the folder on the left. There's a folder on the left. Go down. There's a folder picture. Click on that one. See, you don't have berat.csv. So somehow you have not saved the data from previous section into berat.csv. Go up again. Go up. Yeah. In previous section. Okay, go up. Okay. Now this is after you plot. You're supposed to actually save. Oh, okay. Go up again. Go up again. Somewhere up. Up again and generate. Oh, okay. Now, okay. After you print berat, you're supposed to save it. So this one is print berat, right?
Oh, all right. In here.
Yeah, that's where you generate the data. Now you have to save it into file CSV. So type in this. Okay, type in after print berat. Type in.
Okay.
Enter. np dot save txt. Okay. Now what you have? If you have something like this, all you have to do is press tab. It will basically accept what? Okay. Type again. Okay. So that's okay. And so now the %d change the %d into %i because we are saving in integer, and then because
Okay.
this because we don't have multiple data, remove the delimiter. Yeah, okay, that section remove the delimiter, the comma, remove that one. So comma, terus dihapus terus sampai kurung.
Sampai
Okay, yeah. Okay, now if you run it, then it will generate the berat CSV. Oh, change the size. Change the size into 300, for example. That one is too small. The size. The size.
Okay.
Change it to 300, for example. So you have like a bigger file. Okay.
300.
Okay, run it. Now you have generated the berat CSV. Click on the folder on the left side to check if there is a file called berat.
Oh yeah.
Okay, now the next section will run fine.
So I have to go down, yeah?
Yeah, go down and then find that error again. Remember, go down, down, down. Now this one. If you run it again, the number 10, for example, run it again. Okay. Boom.
Oh.
Okay. Yeah.
And
And then this is the same thing, for example.
so I just
run it again. There.
Oh.
Yeah.
Okay, that's it.
Yeah.
Yes, thank you, Pak. So I'll stop.
Okay. Ada pertanyaan lagi? Is there any question?
That's enough, Pak, from me.
Okay. Thank you, Agus.
Sir,
Thank you.
sir,
Yeah.
sir.
Yeah, Yudi.
For the formula my CSV equal to NP gen from txt, yes, sir. I have an error, sir.
Okay, show me. Yeah. Which one? From generate from txt. Still starting. Okay, import numpy my CSV NP general delimiter print my NP. Saya nggak bisa kali ini. My CSV NP dot gen from txt line dot CSV. Oh, okay. Go down. I want to see the error message. I think it says file. Okay, you don't have line CSV in the file name. Go to the folder on the left side again, and there's no there's always berat.csv but no line CSV. So you have to save it first in the preview section. Okay, after this PLT show, you have to save it into a file. You have to have something like this. Let me just copy this file. Okay, let me add it in the chat section. Add this. Wait. Where's my chat section? Okay. Wait. Chat. Okay. Add that line, the np.save.txt after PLT show. Salah itu bukan. Okay. Copy it first from the chat section. Okay, now run it again. So this one will generate line.csv on the left side. Let's see. Oh, okay. Let's see. Go. It's still an error. There's an error. Go down and then say X point is not. Go up again. Go up again. I think the name is X point, not X underscore point. Sorry, that one is error. X under change X point instead of X underscore point, and then the same thing with Y. Okay, just run it again. Okay, you should see line on the left side actually. See line.csv. So if you run it again, then number 31, it will be fine.
Okay.
Okay.
Sure. Thank you.
Now, what we have done so far, we learned everything. Now, the first statistic that we use is what we call a linear regression. Okay. Now, before we move on to the next one, I want to show you something. Let me just stop this one first. Okay. Now, let's do this. The first step to do, we generate the data set. Let me just go get my data set first. Let me, hang on a second. Let me just put this one in your chat section. Okay. So let me just copy that one first into your section, say for example here, and then run it. Okay. So I'm copying the same data and I run it. So basically, what it does, it creates a file called cluster.csv. So if you click on the folder here, you see that there's going to be a file called cluster.csv. So this is the cluster.csv file. Okay. Run that one first. Okay. Now, what I want to do is I want to create this data and I want to plot it. So something like this. Okay. Now, what I want to do, hang on a second. Where? Okay. Wait. I'm confused. Where is my file? Wait. Aduh, kok susah. Oke ya. Oke, no. Hang on a second. Oke. Sudahkah di-run ini? Kalau udah run, give me your thumb because you already have the cluster.csv. Otherwise, the next step will be error. Okay. So if you run this, there's going to be cluster.csv in your folder. Okay. Now, let's start a new. Assuming we have that file cluster.csv. Okay. And I want to read it. Now what we are going to do is we're going to go. Am I sharing my screen? No, not yet. Okay. Sorry. Okay. Now Now, what we want to do is we're going to use the third library. It's called pandas. We call import pandas SPD. Now, pandas is just like what we call it a spreadsheet, but in a Python format. I want to read that file. I want to read it what we call data frame or data frame, panda read cluster.csv, and then because we don't have header, we say just do this and then print df. Okay, let's move this one chat. Okay, so if I run this, it will basically read that cluster file. Okay, and you can see there is the row from 0 to 302, and then this is the column. There we have two columns, right? XY. Okay, now I want to rename instead of 0 and 1. Let's just rename this df columns. Let's just rename this columns. Let's just rename them into X and Y. Okay. So instead of this, then you just move this print underneath. Okay. If I run it again, so it will print X and Y into the column. Just like if we have Excel, for example, right? This is the column name, and then this is the row. Okay. Now I want to plot this one. Okay, let me just plot this one again. We are going to use import matplotlib sp. Okay, plt. Now I want to print. Okay, yeah, and I want to df plot. Okay, I can plot. Say for example, let me just call it this one. Wait. Okay, let me just plot a. Okay, let me just do this. df plot. I want to plot it the kind of scatter plot. Okay. Scatter. And then the variable, the x is the same as x. The y is equal y. Okay. Let's just run it first. Okay, that works. Okay, let me just put comment here, and then let's copy this one so I can give it to you. Chat, where's my chat? Okay, put it there. So what I'm doing now is I'm reading my cluster.csv file, the one that you have generated earlier, and then I can create columns. And this is the scatter plot of X and Y. Okay. So now what we're trying to do is we want to find the k-mean cluster head. So the whole idea, remember from the experiments or the video earlier, we should have at the end of the day the cluster. This is cluster 1, this is cluster 2, this is cluster 3. But how do we program it? Okay, now what we want to do is we want to have. Okay, let's just put comment here first. Okay, I don't want to plot it, but now I want to use a library called sklearn from sklearn. Okay, cluster import. Import k-means. So there's actually a library. Remember earlier we have to write a program for it, but this time we don't have to. All we have to do is this, and then I can say k-means km is k means cluster is equal 3 because I know a cluster is 3, and then I'm going to fit the data. Fit the data. Fit the data def. Okay, and then find the centroid. Centroid. Oh, this one is equal sign. The centroids is the km cluster centers, and then I want to print the centroid. If I run it, it will print the centroid. But this is not nice, right? Because I don't want to. I cannot see it. I cannot visualize it. Okay, let's just do this. Let's visualize it. Let's plt scatter. I want to plot df and x, and then let's just plot scatter. I want to plot df. Plot scatter. Df equal x. Sorry. Okay. Can we just run it first? Plt show. Okay, let's run it. No, sorry. Df. Okay, wait. There's error. Print cm k labels cmap. Okay, let's just remove the cmap. Okay, labels as type float. Okay, let's just do this. Will it work? Okay. Ada kurung tutupnya yang kurang pas. I think there's a kurung tutup somewhere. Okay, ya. Let's just run this. Wait. Apa yang salah? Sebentar ya. df adalah, oh saya nggak perlu gitu ya. Let me just do this. Let me just do this, df. And then dfy. Okay, print centroids. Okay, now more like it. Okay, let me just copy this code first. Okay, let me just copy this code first, and then let's distribute it to you. Let me give a comment. Okay. So what we are doing here is we just go back here. We read the file called cluster.csv. So we read that file, right? Cluster.csv. And then we create the column into X and Y. Okay, so we have, let me just run this one again. Okay, so we have X and Y, okay, X, Y, and X, Y. And then we want to plot a few this. Now we plot it, but now we want to find the centroid also. Okay, so if we want to find the centroid, the k-means for 3 cluster, right? The k3 means clustering, and the k is equal 3. So this is how we do it. Instead of us writing program, all we have to do is just use this library, which we say k-means the cluster is equal 3, and then fit our data into it, and then it will find the centroid for you. Now I can print the centroid. The centroid is this, but see, the centroid is kind of confusing. The X is 10, the Y is 4. If you can see, this is 10, the Y is 4 right there. Okay. I don't want the colors black. Let's just run it again. Make it nicer. Okay, so you can see the centroidness there. Let's just say the color. The centroid color is equal red, for example. Make it easier to. Okay, so this is the result. We can see the plot of the data, and then these are the centroids. So this is an example of statistic that commonly used in AI, machine learning. Earlier, we talked about linear regression, and this one is how do we cluster this. What we want to do is basically what kind of application can we use for this. Now, assuming the dots are the data from our call center, for example. From our call center, we know that these people are ordering our food. Now, if we have only one store, then so be it. Maybe our store is right there. Oh, well, that's okay. But now, if we have the money to create 2 stores, let's just create 2 stores. Where should we put the stores? And then we run it. Okay. So if we have only 2 stores, these are the best place to set up the store, because this one is close in this region, and then that one is close to that region. What if we have money to create 3 stores? Let's just do this. Okay, if we have money to create 3 stores, this is the place where we should put the stores. What if we have with the money to create 4 stores? Let's just do this. So we can have one there, and we can create 2 there. So this is what we call k-means clustering and the use of it. That's it for tonight. Adakah pertanyaan? Before we close.